Hello, everyone. 7 a.m. Getting ready for work here. But to my programmer friends, I think it's time to do another Leetcode question. It's February, so there are new interesting questions in the website. I've got my coffee over here, um, my living room with my puppies around. So let's get started. Let's see what new problems we have for the month of February, my birthday month. Let's see. There's two ones here. I guess I missed one for yesterday already. Squirrel simulation. Let's see what that is. There's a tree, a squirrel, and several nuts. Position are represented by the cells in a 2 grid. Your goal is to find the minimal distance for the squirrel to collect all the nuts and put them under a tree one by one. The squirrel can only take at most one nut at a time and can move in 4 directions: up, down, left, right, to the adjacent cells. The distance is represented by the number of moves. So the minimum distance here is 1, 2, 3, 1, 2, 3, 6, 3, 3, that's 12. So that's why the answer is 12. So it's basically like a video game simulation where just, you want to find the best way to collect all the nuts, and you want to do that in an automatic fashion. This seems pretty simple. It's just a matter of already starting from the optimal solution. So the optimal solution is just like the shortest path between the tree and the nut. And then you need to factor in the shortest path between squirrel, nut, tree. So there would only be one of those. And then you need to find which one would give you the minimum. So I think we could do this in linear time. So let's go ahead and see. So first I want to collect total if there wasn't any squirrel. And the vim on this thing sucks. So I'm going to use standard. So total plus equals self-distance nut tree. This of course means that I need to define a function called distance. And I need to return the absolute value 0. Abs 1 minus b1. From here, I just need to figure out which nut this squirrel needs to pick first in order to obtain the minimum. So some big number for nut and nut. First, I'm going to subtract from the total actually it has to be twice the distance. Subtract twice the distance of one nut to the tree, and then minimum would be equals minimum total plus self distance nut tree plus self distance nut squirrel. Put the total back into the original so we can move on to the next one. And then by this point we should get the minimum. That was a pretty boring problem. That was pretty easy. Let's see. Yeah. There we go. Let's see if it passes. Yep, passes all the tests. Um, let's see how fast our implementation is compared to everyone else's. Where's ours? I can't find the speed. I think this is the speed. We're either really good in speed or really bad. So, no, we're not in this distribution. Probably really bad, so it's probably around up here. But regardless, it passes all the tests. So, if you're interviewing for a Google or something, you did that in 5 minutes. Not too bad. What's the level of this question?